Hello everyone. Today I am covering the topic of obturation. This is the introduction. Success in endodontic treatment was originally based on the triad of development, sterilization, obturation, with aspect equality important. Currently, successful root canal treatment is based on more broad principles. This include diagnosis and treatment planning, knowledge of anatomy and morphology, and traditional concepts of development, sterilization, and obturation. Washington study of endodontics success and failure suggest percolation of pericolor exudate into incomplete field canal as the greatest cause of endodontic failure. According to endodontic book 5th edition of Engel, 60% of failure caused by incomplete obturation of radicular space. In early radiographic studies of success and failure, Engel indicate 58% treatment failure were due to incomplete obturation. Teeth that were poorly obturated were poorly prepared, procedural errors such as loss of length, canal transportation, perforation, loss of coronal seal, and vertical root fracture. Process of cleaning and shaping development both depend on degree of disinfection and ability to obturate the radicular space. Obturation is therefore reflection of your cleaning and shaping. Obturation prevent coronal leakage, bacterial contamination, seals the apex from periapical tissues fluid, and seals remaining irritant in the canals. So, definition of obturation. Obturation is the last phase of treatment in which canals are filled with biologically inert material as close as possible to cemento-dentinal junction, or in short, we can say that it's an apical stop. Comes to the historical perspective. Before 1800, root canal filling limited to only gold. In 1847, Hill developed first gutta percha root canal material known as health stopping. In 1848, RCF consisted principally of bleached gutta percha and carbonated of lime and quartz. And in 1867, Bowman claimed that first used gutta percha in extracted first molar. In 1883, Perry claimed of using pointed gold wire wrapped with some soft gutta percha, also used gutta percha rolled into points and packed in canals. In 1887, SS White Company manufactured gutta percha point. In 1914, Callan introduced softening and dissolution of gutta percha to serve as the cementing agent through the use of resins. So, when to obturate a canal? The factors which influencing the time of obturations are patient sign-in system first, second pulp and periradicular status, third degree of difficulty, and last one is the patient management. Now coming to the necrotic pulp tissue, it's an asymptomatic, no pain, tenderness or apical periodontitis. Canal should be dry and no exudate and seepage. Presence of fistula sinus tract is not a contraindication. You can go with the obturation if there is no pus discharge, no foul odor or due to anaerobes. Temporary filling is intact, like no breakage and leakage, otherwise it will cause to the failure. A negative culture is obtained. Then second, in vital cases, single seating RCT is advocated, performed under aseptic condition and obturate at initial visit precludes contaminations. Now coming to the terminology, hermetic seal, which is commonly used in the obturation. In ancient Egypt, better known as Hermes thrice greatest, is credited with the invention. The achievement of hermetic seal is often cited as the major goal of root canal treatment. The word hermetic means sealed against the escape or entry of air or made airtight by fusion or sealing. What are the aims and objectives? To establish a barrier to the passage of microorganism from oral cavity to periradicular tissue, to entomb and isolate any microorganism that may survive the cleaning and shaping process. Third one, to prevent leakage into the canal system of potential nutrition that would support the bacterial growth. And last one, to reduce the risk of bacterial movement or fluid percolation into the canal system from gingival sulcus or periodontal pocket. The final objective of endodontic procedure is being the total obturation of root canal space in 3 dimensions according to the Cohen. This is showing the anatomical apex, and we should obturate the canal 0.5 to 1.7 mm short to the apical foramen, apex. Apical extent of obturation, it should always remain in the controversies. One of the controversies in endodontics that remain unresolved is the apical limit of root canal treatment and obturation. Early studies identified that dentino-mental junction as the apical limit of obturation. The cemento-dentinal junction is theoretically the point which divides the pulp tissue from the tissue of periodontal ligament. However, this histological landmark cannot be determined clinically. The dentino-cemental junction may be several millimeters higher on mesial canal wall when compared with the distal wall. Traditionally, the apical point of termination has been 1 mm short from the radiographic apex. Cutler noted that apical anatomy consists of major diameter of foramen and the minor diameter of constriction, with the apical constriction identified as the narrowest portion of the canal. The average distance from the foramen to the constriction was found to be 0.5 mm, with the foramen varying in distance from the apex up to 2.5 mm. Cutler also noted that foramen to constriction distance increases the age because of continuous cementation deposition. Filling short of radiographic apex is generally preferred to overfilling, recommended by many authors. University of Washington's study found no failure among those well-operated cases in which the filling termination slightly short of the apex, whereas 3.85% failure caused with overfilling. So still high degree of success is still achieved if overfilling occurred due to sealer and solid core filling material tolerated by the periodonticular tissues. Controversy also exists with regard to the role accessories canal and lateral canal plays in success and failure. Number of accessory canal range from 1 to 16 but play a little role in periodontical pathosis, with lateral canals are associated with pathosis. Accessories and lateral canals are often obturated by chance or are identified on post-operative radiograph. Investigators compared obturation of lateral canal by 6 obturation techniques in resin block. That result in all techniques were able to obturate lateral canal with sealer, warm vertical compaction, carrier-based thermoplastic gutta percha, continuous wave of compaction, vertically compacted high temperature gutta percha, fill lateral canal with gutta percha significantly better than lateral compaction or warm compaction. So use of sealer enhance obturation of lateral canals. Purposely overfilling to produce a periradicular puff is advocated primarily by proponents of diffusion technique and soften gutta percha technique. Puff or button is designed to compensate for shrinkage of the filling by pulling down tightly against the apex. Now, what are the preparation for obturation? As the old usage goes, what comes out of the canal is much more important than what goes into it. For that great reason, great emphasis had been placed on radicular preparation and debridement, biomechanical preparation, or cleaning and shaping as per the Shielder. What is smear layer? During cleaning and shaping process, a smear layer is produced. A smear layer interferes with adhesion and penetration of sealer into the dentinal tubule and also constitutes substrate from bacterial growth. Also, it interferes with actions of irrigant used as disinfectant. When not removed, it may slowly disintegrate and dissolve around leaking obturation material, or it may be removed by bacteria by products such as acid and enzymes. Removal of smear layer enhances adhesion of sealer of dentine and tubular penetration, and root canal filling material adapt better to the canal walls. How you can remove the smear layer? By using 17% EDTA, sonic and ultrasonic instrumentation with NaCl and MTAD. What is the difference between the overextension and overfilling? An important distinction must be made between overfilling and underfilling and overextension and underextension. Overextension denotes extrusion of filling material beyond the apical foramen, but with the caveat that the canal has been adequately filled and the apex has not been sealed. Over and under extensions refer solely to the vertical dimension of root canal filling beyond or short of the root apex. An overfilled tooth is one whose root canal system has been filled in 3 dimensions and the surface of material extended beyond the foramen, like in the puff. Underfilling refers to a tooth whose root canal system has been inadequately obturated in any dimension and leaving a large reservoir for recontamination and infection. So what key point about spreaders? In the present study, the range of spreaders load during the initial penetration was 0.9 to 3 kg, which agree with the finding of Hervé et al., who reported that maximum forces used by endodontic during root filling ranges from 1 to 3 kg. This range has been considered as safe and that would not produce any vertical root fractures. Holcomb et al. Stated that a spreader load of 1.5 kg could cause vertical root fracture, and these findings may be attributed to the experimental procedure which was performed on mandibular central incisor. Lindor et al. Stated that the possibility of vertical root fracture is increased when D11T spreaders was used due to its greater taper and stiff metal that could withstand 7 kg load without distortion. The spreader load of 1 to 3 kg may be sufficient to condense the master gutta percha cone during lateral compaction, according to the International Endodontic Journal. So this is a table showing the requirement of an ideal root filling cement like sealer. It should be easily introduced into the canal. It should seal the canal laterally as well as apically. It should not sink after being inserted. It should be impervious to moisture. It should be bacteriostatic or at least not encourage bacterial growth. It should be radio opaque. It should not descend to the structure. It should not irritate periradicular tissue. It should be sterile and quickly and easily sterilized before insertion. And it should be easily removed from the root canal if necessary. So what are the material which can be used for the obturation material are the gutta percha cone, silver cone, sealer, paste and new material like Resilon, Endurance and gutta flow. First of all, gutta percha, the first introduced by the Sir Jos A. Almeida, derived from the two words gutta means gum and percha names of tree. Most universally used solid core root canal filling material. And the composition of the commercially available gutta percha was first the matrix, that is gutta percha hardcore 20% organic, filler which is used as inorganic content, zinc oxide 66%, radiopacer which is used as heavy metal, inorganic sulfate 11%, and the plasticizer that is again organic and this is used as wax and resin. Chemically, pure gutta percha or beta exists in three distinct different crystalline forms that are interconvertible. First one is the alpha, that is runny, tacky and sticky, lower viscosity. Second is the beta one, that is solid, compactable and elongatable, higher viscosity. And last one is the gamma X, that is unstable form. So most commercially, beta crystallized form is used. The alpha and beta form differ in molecular repeat distance and single bone forms. Now coming to the advantages, gutta percha, it is inert, it is dimensionally stable, not allergic, antibacterial, no staining to dentin, it is radio opaque, compactable, softened by heat, softened by organic solvent, and removable from the root canal when necessary. And some disadvantages are shrinkage on cooling, lack rigidity, do not adhere to the dentin, and can be stressed. Sterilization of gutta percha can be done by immersing them in 5.25% sodium hypochlorite for 1 minute. Coming to the sealer part, root canal sealer are necessary to seal the space between the dentinal wall and the obturating material interface. Also fill voids, irregular space in the root canal lateral and accessories canal and space between gutta percha points used in the lateral and condensation. It also serves as a lubricant during the obturation process. Sealer in use today can be divided into 4 groups based on the constitution, like zinc oxide usinol sealer, calcium hydroxide based sealer, resin sealer, and glass ionomer sealer. Coming to the classification, according to the Grossman, that is, you can obturate by lateral condensation, vertical condensation, warm gutta percha, sectional condensation, compaction, thermoplasticized gutta percha technique, chemically plasticized gutta percha. According to the Cohen, obturation with a semi-solid material like gutta percha, it should be fitting of primary gutta percha cone, chloroform dip technique, single cone technique, fabrication of customized gutta percha cone, lateral condensation, lateral and vertical condensation method, sectional method, vertical condensation with gutta percha, chloropercha and method modified, Johnson-Callon, Nygaard-Osby and gutta percha Eufera method. Thermomechanically condensation method means thermoplasticized gutta percha injection molded method, paste, hydrophilic plastic root canal filling material, pressure and syringe injection technique, end-to-end related paste. Second one is the canal obturated with semi-solid material like silver cone selection, fitting and cementation simple, split sectional cone technique, technique with apical silver cone, technique with improved silver cone, stainless steel point. Third one is the canal obturation with rigid cone, that is Vitalium and cobalt lumen implant points. According to Engel, the method are listed as follows. First one is the solid core gutta percha with sealant, that is cold gutta percha point. It includes lateral compaction and variation of lateral compaction. Second is the chemically plasticized cold gutta percha, that is essential oil solvent. Third is eucalyptus. Fourth is chloroform, and last one is the halothane. The last one is the canal wound gutta percha technique, in which we can use vertical compaction, system B compaction, sectional compaction, lateral and vertical compaction, endotech 2 thermomechanical compaction, microseal system, and JS quick fill or ultrasonic plasticizing. The last one is the thermoplasticized gutta percha, in which syringe insertion can be done, obtura use or injection R-fill and backfill comes. Solid core carrier concentration includes thermofill and densefill, soft core and 3-DHGP and silver bonds. Apical third filling can be done by the light speed simplified dental chip and C, its calcium hydroxide. Injection or spiral filling done by the cement, paste, plastic and calcium phosphate. Now prerequisites for the canal: obturation, canal preparation, spreader selection, primary master cone selection, sealer mixed and placement. Similar to the apical environment or larger, match the taper fit to within 1 to 2 mm of the working length. Second one is the match with last instrument used for proper fit, that is visual test, tactile sensation, patient response and radiographic test. Coming to the lateral compaction technique, rubber dam application, SS opening and biomechanical preparation should be done. Master gutta percha point selected corresponding to the master apical file. The point is tried for correct fit and length and radiographic is taken. Root canal sealer, cement is mixed to proper consistency. Apical half of the selected master cone is coated with sealer and is inserted into the canal to predetermine depth. Pre-selected finger spreader is inserted between the canal wall and the master point to a depth 1 mm short of working length, and spreader is left for at least 15 seconds. Accessories points are coated with sealer cement introduced in the space created and are condensed upon one another. This is how we can do by the lateral condensation. Accessory cores must occupy the space left by the spreader, and otherwise then the air and sealer filled space will result in the obturation. Condensation and addition of gutta percha cone continues until the spreader will reach no more than 2 to 3 mm into the canal. Forces generated by vertical loading of the spreader are vertical and lateral, and heat serve the gutta percha point and allow consolidation deep into the canal. Disadvantage: it is time consuming. First of all, difficult in fine and curved canal, does not achieve a dense homogeneous mass. Filling of lateral and accessories canals are achieved, cannot adapt to the canal wall irregularities. Chances of stress development and fracture is more, that is 1.5 kg and 5 kg is used. Then the inverted point technique. It is indicated in the open apex cases, canal with fairly parallel wall. Second one is the gutta percha cone is selected as primary point, and the serrated butt end of the point is inverted and tried in the canal. Should go to the working length and should exhibit tuck back. Radiograph is taken to confirm its position. Canal is obturated like in lateral compaction technique with this cone as primary cone. Now the variations of lateral condensation. One is inverted cone method. Second is the tailor-made gutta percha roll. And third is the chemically plasticized gutta percha. Tailor-made gutta percha roll. This is how we use the tailor-made gutta percha roll or roll cone technique. A number of heated coarse gutta percha points are arranged butt to tip on sterilized slab. Points are rolled with the spatula into the rod-shaped mass. By repeated heating and rolling, the roll of gutta percha is formed to approximate size of canal to be filled. Before trial point testing of tailor-made roll, gutta percha should be chilled with ethyl chloride spray. Chemically plasticized gutta percha technique. This is a variation of very old obturation method called Callan-Johnson technique, first given by Callan in July of 1911. Nisgard Ostby technique. Several pieces of gutta percha are cut into a dappen dish and sterilized with a small amount of chloroform or floor percha. A small amount of floor percha is streaked into the wall of the dry root canal with a fine root canal spreader or other suitable instrument. Then the apical third of master cone is dipped into the percha paste and the entire master cone is gently responsive into the canal. The material in the canal is now forced laterally with root canal spreader and making room for additional gatta percha cone. Each piece of gatta percha blend with gatta percha and chloro percha already in the canal to form a homogeneous mass which conform quite adequately to the configuration of the root canal system. Coming to the warm vertical condensation technique. Schilger-Boston technique, system bead touch and heat or sectional method. Schilger-Boston technique, three-dimensional technique, Herbert Schilger 1967. It is advantage are merging of gatta percha into a dense homogeneous mass, dense three-dimensional fill and obturation of lateral and accessories canal. It is indicated in the large lateral canal and internal resorption cases. It includes plugger and heated source, and Schilger pluggers are available in variety of sizes. The technique like fitting the master cone gatta percha, pre-fitting the vertical plugger, heat carrier instrument, and root canal sealer. Technique is like this. After BMP, trial insertion of thick plugger we do at junction of coronal and middle third. Then the thin plugger at junction of middle apical third is used, and the primary gatta percha point is selected and inserted into the working length. Then thick plugger is heated and gatta percha cone is seized off. The hot plugger is used to condense vertically with short circumferential strokes. Pressure from the plugger combined with apical counter pressure fills the lateral canals as shown in the diagram. Heated instrument is inserted into the apical region once again and pressure 3 to 4 mm into the gatta percha is given, it heated and plasticized, and it removes small amount of gatta percha. The small plugger condenses the heated GP apically, and plugger should remain in the canal until the gatta percha cools. After the apical third filling is over, back filling can be done with injectable system. Cannula of the gun contact the apical gatta percha pressure. Pressure on the cannula is gently released and a small amount of gatta percha is expressed, and medium-sized plugger pushes the gatta percha apically and homogeneous mass is obtained. Now the disadvantage of this method is many steps involved, like time consuming, so that uncontrolled heat with heat carrier, it can cause heat carrier heated over a flame, can reach an average temperature of 321 degrees Celsius and can transmit a temperature of 140 degrees Celsius also. It requires a wide tapering preparation. Now coming to the system B, it consists of system B, heated source, thermostatically controlled electric device that supply heat. It has continuous and touch mode, temperature temperature 200 degrees Celsius and period of time determined by the operator. This is the handpiece. It holds the tip connected to the heat source by a cord and is a ring switch which is pressed to activate the handpiece. Now these are the plugger tips available in standard size as well as non-standardized size. Medium system B tip, it's 0.06 taper, and medium fine system B tip is 0.4 taper. Technique in 3 stages. First we do cone fit and plugger fitting, then down pack technique and then backfill technique. Cone fit. Appropriate site gatta percha cone selected. Must fit in the last 1 mm and to full length. Minimum tuck back of 0.5 mm of apical tip of gatta percha cone. Then we use down pack technique. In this, primary point coated with sealer and pushed to place. Heated source present at 200 degrees Celsius. The tip is activated by pressing the ring switch on the handpiece. Cone is seared off at orifice. Preheated plugger driven smoothly through gatta percha to within 3-4 mm of binding point in 2 seconds, and heat switch is released. This is how we do the obturation. Then plugger continues to move apically. Cold plugger held by additional 10 seconds under sustained pressure. To remove plugger, heat switch activated for 1 second followed by 1 second phase, pause. Plugger then quickly withdrawn and radiograph confirmation is done. Backfill technique. The same gatta percha cone coated with the sealer and positioned in backfill space. System B with the same plugger and inserted at 100 degrees Celsius for 1/4 second only. Then immediately plunge plugger into the backfill cone and hold in place for 3 to 5 seconds. Another cone placed and procedure repeated. Final plugging with a large cord regular plugger is done. Touch and heat. This is how the instrument looks. It is given by the Clifford J. Riddle, and it's an electronical device especially developed for the warm gatta percha technique. It is battery operated or AC models are available. Consists of control unit, heat carrier, which is connected to the unit by a cord, and tips are interchangeable with those of system B. Advantage: it will accessory canal and homogeneous filling. Disadvantage: it voids inadequate control of the depth of insertion of the filler. Small plugger is ineffective and plugger binding apically may split root. Disadvantage: it produce excesses like 0 to 1816 degrees Celsius, 816 degrees Celsius, twice as high as that produced for an open flame, might lead to overheating the gutta percha, may damage periodontal ligament in teeth with narrow roots such as mandibular anteriors. Spreader not uniformly heated to the same temperature throughout its entire length. Now, difference between the touch heat and the system B: touch and heat, same basic setup, but without thermoset and power control knob, temperature is not controlled. Half the cost of system B. System B thermostatically controlled and relatively expensive. Now, warm lateral compaction, that is lateral and vertical compaction of warm gutta percha. Lateral compaction, length controlled, so that advantage over thermoplasticized technique. Considering the ease and speed of lateral compaction as well as the superior density gained by vertical compaction of warm gutta percha, Martin developed a device that disappeared to achieve the best quality of both technique called endodontic 2. This is the endotech developed by Howard Martin and Fisher, designed to compensate for the void created during the cold wetting of cone during lateral compaction. It consists of endotech handpiece, cordless handpiece with an activator button and battery operated. Endotech tips comes in 21 mm long, two sizes. One is larger tip, that is number 45, and the smaller tip, that is number 30. It is autoclavable and may be adjusted to any SS accumulation. The temperature ranges from 315 degrees Celsius to near about 44 degrees Celsius. 170 degrees Celsius allow the apical 60 mm of the tip in within 5 seconds and take 2 seconds to cool down. The procedure, how we use it, like canal preparation with continuous taper design and with definitely apical stop is done. Dry the canal, then apply sealer. Primary master cone adaptation with hand or finger spreader or plugger, and then additional gutta percha placed to reduce the possibility of warm gutta percha losing the primary point. Endotech tech is placed in the canal to full depth alongside the gutta percha. Lateral activator button is pressed and plugger spreader moved in clockwise direction, and release the heat button and the plugger cools immediately. Now remove in counterclockwise direction. This motion creates a space for additional point to be added. Procedure is repeated. Now the plugger can be used cold to compact the softened gutta percha. In this manner, the canal is completely obturated by using endodontic plugger and vertical pressure with sweeping lateral pressure. The uses: it can be done in warm lateral compaction, gutta percha removed during retreatment or post preparation, or elimination of void created during the normal lateral condensation. Difference between endotech and touch and heat: endotech is cordless, lower temperature and heavy. Touch and heat is with cord, higher temperature and comparatively lighter. Advantage of endotech: combine the best of two techniques, lateral compaction, that is relatively simplicity, and vertical compaction, superior density. Tip can be used as both as plugger or spreader. Heated tip is able to advance apically with minimum exertion, create less stress on root structure, that does called lateral compaction. Disadvantage: it increased time needed for obturation, spreader breakage, heaviness of the handpiece, highlight, decomposition of gutta percha. Now comes to the thermopack device. Is used as a lower temperature, 42 degrees Celsius for warm lateral condensation, 59 degrees Celsius for vertical compaction. It prevents decomposition of gutta percha. Second is the sectional condensation by Coolidge in 1947, also called as the Chicago technique, as it was performed by Coolidge and Linkwitz in Chicago dentist, one of the earliest modification of vertical compaction method. The technique used as a plugger should fit the prepared tapered canal loosely and extended to within 3 mm of the working length. Primary gutta percha point is blunted and carried to the place to fit 1 mm short of working length, and 3 mm of the tip of the point is clearly excised with a scalpel. This small piece is then luted to the end of the wound plugger and canal lined with sealer. Then gutta percha tip is wound by passing through alcohol frame and then carried to the canal. And soften, it can be done by the chloroform or halogen also. This is how the backfill using thermoplastic gutta percha technique is done. Now come to the thermomechanical compaction. It is introduced by Max Spender in 1978. The principle is automated rotary device, heat generated by friction soften and the gutta percha. Design of the blade forced into the material apically. Max Spender compactor resemble a reverse handstone file or reverse screw design. It is made up of stainless steel, fit into a latch type handpiece, speed between 8,000 to 20,000 RPM, and used with regular beta phase gutta percha cone. Fitting the master cone with the sealer compactor alongside the gutta percha to 3 to 4 mm from prepared length and activate the compactor on full speed of 1 second and gutta percha plasticized by friction within withdraw and compaction. The advantages are canal could be filled in seconds, ability to fill a very irregular spaces and teeth with risotto default, gave a dense fill and conservative use of gutta percha. The disadvantages are fragility and fracture of instrument in canal less than size 50 and curved canal, overfilling, void formation, poor seal, use of speed higher than recommended, and difficulty in mastering the technique. These are the gutta condenser given by the Melifier, blunted tips having a fluid depth reduced and less likely to fracture. Then engine plugger given by the Zippler, move closely resemble an inverted K-file design with a reverse twist. Anti-condenser, again given by the Maxman in 1993, modified of the original Maxman compact, made up of nitide flexibility, which give flexibility and can be used in the curved canal. Blunted blades and tips prevent gouging, and also called microfo compactors and pack Mac compactors. It is supplied as engine driven and hand powered, used as a nighttime matic handpiece. It has a slower speed around 1000 to 4000 RPM. Then come to the microseal system, that is given by the Chevron Endo, and it consists of microseal condenser, microseal spreader, microseal gutta percha heater, gutta percha syringe. It's a special formulation of gutta percha, basically low fusing gutta percha as a cone, ultra flow fusing gutta percha in cartridges. This is how microseal condenser look. Engine driven by nickel titanium condenser, reverse helix design. It is available in 0.02 taper, that is size coming from 25 to 60, and 0.04 taper size 25. Designed to be used in 1:1 electric handpiece, and the speed should be 5000 to 7000 RPM. The angle between blades and axis, it varies from 60 to 30 degrees and decreases in amplitude from handle to tip. More open in the coronal part, forces directed apically act as a plugger, and more closed in the apical part, forces directly laterally act as a spreader. Comes to the micro seal spreader, that is nickel titanium, finger spreader and engine driven, both comes in this. Finger spreader is 0.02 taper, size 20, 25, 30, and 0.04 taper, size 25, used with continuous rotation motion. Engine spreader 1:16 reduction handpiece and 300 RPM can be used. Then come to the microseal gutta percha cones. It is a fusing alpha phase gutta percha, available in 0.02 taper, size 25 to 60 for narrow canal, 0.04 taper, size 25 for larger canal. It is not very radio opaque. Coming to the microflow cartridge, it is ultra low fusing alpha phase gutta percha, tacky consistency, allow for through addition to canal wall, single use cartridge, so infection control and less wastage of gutta percha. Then coming to the microflow syringe, it is autoclavable heavy duty metal construction with larger finger supported for easy extrusion of microflow cartridge. Microseal gutta percha heater. It is used to warm gutta percha in cartridge. Working temperature is reached within 45 seconds in thermoplasticized control. Maintain ideal working temperature of cartridge throughout treatment. Then coming to the Jazz Quick Fill Jazz Dental Corporation given by the Sweden in USA. Use pre-coated compactor titanium core device, resemble latch type endodontic drills in sizes 15 to 60, coated with the alpha phase gutta percha. It has an advantage that does not need to be heated, and it is neat and easy to use, but its advantage that it is tendency of voids. How it can be used? It is fitted to the prepared root canal, spun in the canal with a regular low speed latch type handpiece, compacted to the place by design of the quick free core. After compaction, two choices: the compactor may be removed and the final compaction completed with a hand plugger, or the titanium solid core left in the place and separated in the coronal cavity with an inverter cone burr. Fitted to the prepared root canal, spun in the canal with a regular low speed latch type handpiece, compacted to the place by design of quick fill core. After compaction, two choices: the compactor may be removed or final compaction complete with a hand plugger, or the titanium solid core left in a place separated in the coronal cavity with an inverted cone burr. Then coming to the automated plugger, it is also called as canal finder plugger. Stepwise flexible plugger shaped such as like a telescope used in the canal finder handpiece. It delivered a radio opaque vertical stroke that varies between 0.3 mm to 1 mm. Telescopic design catches gutta percha and compacts apically. Accessories points are added in lateral void produced. Ultrasonic plasticizing gutta percha, first suggested by the Moreno from Mexico. Cavitron ultrasonic scaler with a PR30 insert. It should be used only in anterior depth. Technique: first you place gutta percha point to virtually fill the canal, then insert the attached endodontic instrument into the mask, activate the ultrasonic instrument without the liquid cooling. The gutta percha is plasticized by friction and advanced to measure root length, final vertical compaction with hand or fine plugger. Coming to the thermoplasticized gutta percha technique, it consists of syringe insertion with gun like beta phase, obtura, obtura 2, alpha phase is by ultrafill. This is obtura, also called as a high heat technique, available as obtura in 1983. Obtura gun, also called as gutta gutch, a pistol grip syringe, used pellet of gutta percha which were loaded in chamber of obturation gun. It used silver needle, more flexible and retained heat to keep the gutta percha soft. This was later modified and commercialized as a Obtura 2 in 1991. Obtura has no digital display, whereas Obtura 2 has digital display of temperature reading, syringe made of a stronger heat resistant plastic material, highly polished chamber and well-fitting round plugger. These are the gutta percha pellets available as a beta phase gutta percha pellets. Variation in consistency of the gutta percha, it's to improve the flow and regulatory viscosity. Regular flow gutta percha, easy flow gutta percha. Two kinds of gutta percha available. The first one is the regular flow gutta percha. This is homogenized formulation with superior flow characteristics, cool rapidly and hardens within 1 minute. Easy flow gutta percha has longer working time, 10 to 15 seconds more than regular, less viscous, high flow form, soften as a lower temperature and used with 25 gauge needle. Temperature which is used is 160 degrees Celsius to 200 degrees Celsius. Depend on the gauge of the needle. Smaller the gauge of the needle, higher the temperature needed. It extruded gutta percha has temperature of 62 degrees to 65 degrees Celsius and remains softened for 3 minutes. Indication in the complex cases which require extensive compaction, small curved canal and inexperienced clinician. Technique: it requires minimum size 40 preparation in body of canal, continuous tapering funnel from the apical matrix to canal orifice. Needle and plugger should reaches within 3.5 to 5 mm of the terminus and fit loosely to the dead point. The compaction necessary is to close space and gaps. Compensation for shrinkages, gutta percha cools. So how we do by the obtura is the plugger fitted to 3 to 5 mm within the apex. Pre-heated gutta percha in the gun injected passively into the apical 4 to 5 mm. Needle is backed out. Plugger compact the plastic gutta percha apically and laterally. Segmental technique whereas 3 to 5 mm of gutta percha is sequentially injected and compacted. The uses: complete or primary obturation, that is total and segmental, backfilling sectional technique, and managing canal irregularities like fins, webs, and cul-de-sacs. Internal resorption and accessories lateral canals. Combined technique can be used by obturation master cone and obturation injection around the point. The advantages are void elimination created during normal lateral condensation of warm gutta percha. The disadvantage that it can cause breakage and kinning of spider. This is how this shows. So in gross overfilling of root canals. Now the coming the ultrafill 3D. It's a low heated injectable gutta percha system introduced by the Mekanovich and in 1984 consists of heating unit, metal syringe, and a cannula pre-filled with gatta parcha. The metal syringe, also called as a peripress syringe, do not have a heating elements, and the heating unit that has slots to receive the needle used to warm the cannula, and it preset to 90 degrees Celsius. Now the comes to the cannulas, pre-filled with gatta parcha and has attached needle of 22 gauge, that is 0.7 mm diameter. It is disposable, contain enough gatta parcha to fill at least 1 molar, available in 3 colors. That is, one is white, that is regular set. Setting time is 30 minutes. It is low viscosity and compaction not required. Second one is blue, that is setting time 4 minutes. Condensation possibly but not required. Third one is green, that is setting time is 2 minutes. High viscosity and must be condensed. Cannula is chosen and needle may be bent to the barrel of the syringe. Cannula is placed in the preset heater at 90 degrees Celsius for 15 minutes. Cannula is placed in injection syringe, during which time it loses heat rapidly and drop to 70 degrees Celsius, ready for injection. Material is injected in the preparation at 42 degrees Celsius to 45 degrees Celsius. Working time is 1 minute. Injection procedure is technique sensitive. Trigger should be squeezed slowly and steadily. Excessive pressure can cause fracture the cannula and gatta parcha extrude through back to the canal. Advantages: varied viscosity, can be compacted vertically and laterally, required minimally pressure during compaction. Increased patient comfort, thermoplasticized at low temperature, disposable cannulas, can be used for backfilling, flow into canal irregularities. Can be used for different cases like large canal, retrograde fillings, internal resorption cases, perforation, lateral canal cases, ledges, open apex. And the disadvantage, as requires a wide middle 1/3 preparation to at least size 70. The filling can be pulled out if the injector is removed prematurely. Difference between the ultrafill and the Obtura 2. Ultrafill is low temperature, gun has no heating elements, separate oven, no digital rated, use 22 gauge needle, working time of less than 1 minute. Whereas in Obtura 2, high temperature, digital display of temperature, there is needle is 18, 20, 22 and 25 gauge and remains often for 3 minutes. Coming to the solid core carrier insertion. It is 2 pre-coated carrier and the operator coated. The pre-coated carrier contains thermofill and dense fill, soften core in 3D GP and 1-step Obtura. Operated cool comes in alpha seal and success fill. Thermofill. Solid core carrier insertion in 1978, Ben Johnson described a unique yet simple method of canal obturation with thermoplasticized alpha phase gatta parcha carried an endodontic file. Thermofill is patent endodontically obturator consists of a flexible, centrally carried size 4 to match standard endodontically file that are uniformly coated alpha phase gatta parcha. Thermofill device was introduced by Tulsa Dental. In its current version, the Thermofill Obtura, which is available in the UK from Dentsply Malfare, feature a flexible plastic carrier coated with the alpha phase gatta parcha. The obturator is carried into a special oven with a temperature and time control. The heated gatta parcha becomes thermoplasticized and the obturator is then inserted into the root canal to the working length. This is the thermofill. The thermofill obturator, this is 25 mm in length and is tapered, highly flexible plastic carrier coated with a low molecular weight. Alpha phase gatta parcha comes in a size from 20 to 140 and the plastic carrier feature for longitudinal groove along its complete length to facilitate retreatment. The thermofill verifiers, these are 0.04 taper nickel titanium hand instrument which are used to check the taper of canal and select the proper obtura. The thermoprep oven, this allows uniform, predictable and controlled heating to the gatta parcha by allowing precise temperature and time control. The thermocut burr, this features a smooth non-cutting round head which is used to serve the plastic carrier without any risk of perforation. These burrs are available in size 10, 0.2, 0.014 and 0.016. The post space burr, these are long spherical non-cutting burr which are used to prepare the sphere for the dowel post. These burrs are available in 2 sides, that is 005 and 007, and the 2 length, that is 25 mm and 31 mm. Now come to how to use the thermofill. Selecting the verifier. Select a verifier corresponding in size to the last instrument used up to the working length. This verifier must slip in easily up to the working length and present a sag sensation to resilient tuckback on withdrawal. Selecting the obturator, select the thermophile obturator corresponding to the verifier which adopts itself passively to working length, and that reference and silicon stop must be used. Heating up the obturator in the thermo prep oven. The silicon stop must be below the support. Second, press the button corresponding to the size of thermophile obturator, and then press the start button on the front of the altar side support. Then drying the root canal, mixing and adopting the cement. For drying, we can use paper points. For mixing, you can use a top seal and drying with the paper point. Then fill the root canal. Carefully extract the obturator from its support and insert it immediately into the root canal with a slow and firm and continuous movement in the apical direction. Ensure that the movement is always in the direction of the carrier too, and it prevents it from bending. Now withdrawal of the protector and the shank after obturation. After radiograph confirmation that the root canal is filled up to the working length, the plastic carrier is separated using a burr thermocut burr used on a turbine that is 3 lakhs RPM without spray. Then extracting the excess gutta percha, it can be done by endodontic excavator and remove the surplus gutta percha. Now the post-stress preparation. In order to eliminate the coronal part of the filling, use the post-space burr to drill the post-space. Uses to fill internal resorption active cavities. Advantage of thermophile is the shortness of leaning curve, speed of clinical application, apical control of fill, conservative enlargement of the root canals, and 3-dimensional obturation and apical sealing ability. Now apical third filling. It can be done with the gutta percha, light speed simplified obturator or fiber fill obturator. Without gutta percha, it can be done by dentinal chips, calcium hydroxide, mineral oxide aggregate. Simpler fill, it is a light speed technique originally developed by the Senia to complement the canal shape created using the light speed instrument. The apical GP plug size is the same ISO size as the light speed master apical rotary. Use of stainless steel carrier to place and compact a 5 mm segment of gutta percha into the apical portion of canal. Advantage, it helps conserve dentin because of the light speed instrument technique. It eliminates additional internal forces since no spreader and plugger is used to compact the apical plug. It is simple and no carrier is left in the canal. Then come to the fiber field obturation. It is a combination obturation technique. It combines a post and obturator in a single unit. Apical 5 to 8 mm gutta percha used, attached via thin flexible filament, and for negotiation of moderately curved canals. Coronal 2/3 is a resin core post comprised of a unidirectional fiber in an organic resin matrix. Fiber fill obturation system consists of fiber fill obturation, fiber fill root canal sealant, dual cure resin sealer, and fiber fill primer and bonding agent. Advantage, it can be bonded to the tooth and dramatically reducing coronal leakage, and the disadvantage that it is difficulty of the retreatment. Dentinal chip apical filling. Dentin filling will stimulate osteo and cementogenesis. Advantages are the prevent overfilling and confining the irrigating solution and filling material to the canal space. It is lead to quicker healing, minimal inflammation, apical cemental deposition even when the apex is perforated. But the disadvantage that the dentinal chip is, if infected, are serious determinant to the healing. Technique. The canal is totally debribed and shaped, then gets Glidden drill or Henstrom file is used to produce dentin powder in the central position of the canal. This house are dental chips produced by using Glidden, then chips being compacted by blunt instrument and compaction of dentin chips apically end of the instrument. Now calcium hydroxide apical filling. Cementogenesis, which is stimulated by dentin filling, appears to be replicated by calcium hydroxide as well. Calcium hydroxide dissolves away from the apex faster than do dentinal chips. Method to use calcium hydroxide, it can be placed as an apical plug in either a dry or moist state. Dicalcium hydroxide comes in powder form that may be deposited in the coronal orifice from a sterilized amalgam carrier. The bolus may be then forced apically with a pre-measured plugger. Tape to place within the last size apical file that we used. 1 to 2 mm must be well condensed to block the foramen. Blockage should be tested with a file that is one size smaller. moist calcium hydroxide. It can be placed in a number of ways. First, amalgam carrier and by plugger, plantarospiral injection from one of the commercial syringe loaded with calcium hydroxide, that is Calasat or Tancanal. Then the calcium hydroxide deposit should be thick enough and well condensed, serve not only as instrument to the cemental growth, but also as a barrier to extrusion of well compacted gatta parcha obturation. Never approach to obturation. Approaches to obturation. The monoblock concept. The term monoblock literally meaning a single unit. An ideal endodontic filling material would create a monoblock. This term refers to a continuous solid layer that consists of an each layer of canal dentin, implement with resin tag that are attached to a thin layer of resin, cement, and that is bonded to a core layer of resilon which make up the bulk of filling material. The monoblock concept means the creation of a solid bonded continuous material from one dentin wall of the canal to the other. One added benefit of the monoblock is that researcher says that it strengthens the root by approximately 20%. Resilon. Resilon is a thermoplasticized synthetic polymer based on polymer of polyester containing bioactive glass and radioactive filler. The sealer with Resilon is FNAV root canal sealant. It is a dual curable dentin resin composite sealer, and the matrix is a mixture of ethoxylated glymethyl acetate biphenyl and epoxy, that is bis GMA, and a UDMA and hydrophilic disinfectional methacrylate. Come in the active GP form. The active GP gatta parcha is a glass ionomer filler containing gatta parcha cone that is also coated with a layer of glass ionomer filler particle at a thickness of 2 micron along with the cone surface. By doing so, a stiffer gatta parcha cone is achieved that transform into a gatta parcha core cone, enabling the latter to functionally as both a tapered filling cone and as its own carrier cone, thus avoiding the need for a separate interior carrier of plastic or metal. The cone can be bent up to 180 degrees Celsius without showing any 180 degrees without showing any sign or symptom of delamination of the coating, and are measured in size to preparation created by the file. The presence of glass ionomer filled coated gatta parcha cone also allow to be bonded to the root dentin via glass ionomer sealer and creating a claimed single cone monoblock obturation. Then come to the gatta flow. Gatta flow is a cold flowable technique that combines fine gatta parcha particle with polymethyl siloxane sealer containing a plastic capsule. The gatta flow capsule is triturated for 30 seconds and the sealer is inserted into the root canal using dispenser and canal tip provided by the manufacturer, and the viscosity of the sealer diminished under pressure, enabling flow into the smaller canal. The gatta parcha master cone is also coated with the sealer and slowly inserted into the canal, and additional backfill is performed with the sealer by reinserting the canal tip to dispense additional sealer to the space between the master cone and canal wall. The last 2 mm of gatta parcha is removed from the canal orifice with a heat source followed by the placement of provisional restoration. Then biological obturation technique aimed at introducing hard tissue closure of the root canal or ingrowth of new connective tissue into the canal from periapical area. Experiment have been reported in which a gel of collagen and biological active chemical was applied in the root canal. With this method, both in growth of tissue at apical and intracanal calcification have been observed. There are attempts to induce in growth of new connective tissue into the root canal by means of blood clot. In this experiment, the root canal is instrumented through the apical foramen but otherwise prepared in the normal way. Periapical bleeding is then provoked when the canal is filled with blood and it is sealed bacterial tight at a distance from the apex. Now, how to evaluate the obturation? The only mean of immediate assessment in radiograph, which is imprecise at its best. Then second is the symptom. Third is the presence of symptoms for a few days after obturation is common and probably is unrelated to inadequate sleep. This reflects a different phenomena which is likely tissue irritating from the procedure. First one is the radiographic criteria. Good obturation cannot be seen as a radiograph. Only fairly close discrepancies are visible, and these whites are or deficiency may or may not related to the lack of C and may result in long-term failure. Second is the radiolucency voids within the body or at the interface of obturating material dentinal wall represent incomplete obturation. Density. Material should be uniform density from the coronal to apical aspect. The coronal region are more radiopaque than the apical region because of differences in mass of material, the margin of gutta percha, and should be sharp and distinct with no fussiness indicating close adaptation. Then the length, the material should extend to the prepared length and be removed apically to the gingival margin and orifices. Taper, the gutta percha should relate the canal's shape, that it should be tapered from coronal to apical region. Taper need not be uniform but should be consistent. Then the fourth one is the restoration. Whether permanent or temporary, the restoration should be contacting enough dentin surface to ensure a coronal seal. These are the references articles from which this seminar made. Thank you.